We're joined now at the Public Affairs Console in the Mission Director Center by Bruce Reed. He is the mission manager for the Landsat Data Continuity Mission spacecraft for NASA's Launch Services Program. And Bruce will be walking through some of the things that we've been doing to get the Atlas V and the LDCM satellite ready for our launch today. Bruce, first of all, tell us a little bit, have there been any unique requirements that we've had to do to prepare for LDCM?
Well, George, the LDCM spacecraft is unique, as are all the NASA spacecraft. And so it's always a challenge on every mission to meet those particular requirements. For instance, the LDCM spacecraft needs to have 60 minutes of continuous sunlight after separation. So we've designed the trajectory such that that will occur. And also they have very stringent tip-off rate requirements. So the launch vehicle will do a compensation maneuver just before separation. So every NASA mission is unique in its own way, and we work out those requirements to make sure everything is met.
Well, Ruth, we have some video now. If you would tell us a little bit as we go along some of the things that are happening here.
So this is the Atlas V booster rolling out to the pad. This is all the way back in October. And you can see the booster is pretty large. It's about 100 feet long. And it looks like they've got the front end of it attached to the 60-ton crane at the mobile service tower. And we have a breakover fixture at the rear of the booster to allow it to go into the vertical position. And you see a good shot there of the RD-180 engine and the twin nozzles. So the booster is positioned over the fixed launch platform, and it's aligned and lowered down onto the launch heads. So this is the Centaur stage. You can see the RL-10 engine there, built by Pratt & Whitney Rocketdyne. This is a cryogenic stage, liquid oxygen and liquid hydrogen, and it'll be hoisted atop the interstage adapter, which is on the booster. So this is the fully encapsulated LDCM spacecraft. Encapsulation occurred at the Astrotech facility on Vandenberg Air Force Base. And then it's set up on top of the transport trailer and moved out to Space Launch Complex 3. This was on January 25th. And you can see we have air going into the payload fairing. This is the environmental control system to keep the payload cool and to meet the humidity requirements. And they're going to go ahead and attach the encapsulated assembly and hoist it up into the tower. And you saw a good shot there of the LDCM logo. The black portion at the bottom of the payload fairing is the isolation diaphragm, which maintains those environments throughout the entire transport and hoist operation. And they'll go ahead and put this through some doors that open and center it on top of the Centaur. And then we'll lower it down carefully. And I think you'll get a good shot here of the Centaur equipment module as it's being carefully lowered down, and then they'll go ahead and install all the bolts and ready for launch.
Bruce, thanks very much, and best of luck to you and the Goddard team, the Orbital Sciences team, and the entire NASA Launch Services program that's here, been working on this for quite some time for today for a launch that has held the schedule here at the end pretty well. So Bruce, thanks very much for coming by.
Thank you, George.